and welcome to the 18th lecture on pressure measurement of Unit 3. So, in this particular lecture, we people are going to extend the elastic type of sensors. So, what is the elastic type of sensor? In the previous lecture also, we people have studied some of the elastic type of sensor. So what is elastic? Elastic is nothing but one type of rubber-like structure that is much more helpful uh, so as to measure the pressure. Now, what is the impact which is going to be intact for the measurement of pressure? So here, when the pressure is applied on the particular component or particular device, the resultant output is generated in the form of deformation. So the input which we people are applying, that input is based upon the input as a pressure. However, that input will utilize for the purpose of deformation. So this deformation is carried out as the function of the input pressure which has been applied. So in the previous lecture, we people have discussed about the Bourdon tube. So what are different types of Bourdon tube that we people have seen and how they are used for the measurement of pressure that we people have seen thoroughly. So there are various types of Bourdon tube. So first one which we have studied was a C-type Bourdon tube. So this C-type of Bourdon tube is represented as shown in the diagram, and here is the tip which is generated at an output. So this is connected to your mechanical accessories associated with the gears, and this one is actually connected to the pointer. So here we people are having the pointer. When we people are applying a pressure, when we people are applying a pressure as an input, this pressure will try to pass through this particular Bourdon tube, and due to its elasticity, what is going to happen is try to move in the forward direction. So this will try to elongate likewise. Okay, so this is the structure. It will try to move in the upward direction. So this pinions and the mechanical accessories, as it is connected over here, this will try to pull this one to the backward side. And when it is pulled towards the backward side, the gears are connected to this one, and the pointer will move on the scale. So scale will try to represent the input pressure which has been applied as an input to it. Okay, so this one is our C-type Bourdon tube. Then we have seen the helical type of Bourdon tube. So structure of helical type of Bourdon tube is like this. So likewise, helical type of structure is provided over here, and this helical type of structure is associated with the pointer, and the input is given from this particular aspect, which is having the path to pass the airways. Likewise, I will represent it with the another color. So likewise, a representation of this path of the pressure is provided. Why actually we people are saying the elastic sensor for this one? Because this is going to be elongated one. This is going to be elongated one when we are applying the input pressure for this particular helical type of Bourdon tube. So this will try to move in the forward direction, and this pointer is connected to the upper tip of or the existing point across the pointer. So here is the scale, and it is trying to highlight the structure. So it is trying to highlight the structure. So when we are applying a pressure as an input to this one, so pressure I have applied, this has been elongated. It is going to affect over the pointer, and pointer will move either to this direction or either to this direction, depending upon the input pressure which we have applied. Okay, so this one is the helical type of Borden tube. Another one which we have seen is the spiral type, and the structure of the spiral type is like this. So this is the structure of the spiral type. Double structure is provided over here, and from this particular structure here we people are applying a pressure as an input. So what is going to happen with this particular one? Actually, this one is also a round one, so that it will try to generate a path. In the other manner, I will show it in a simple form. So simple form is like this. So over here, as a one particular structure which we people are going to utilize, and here we are having the output. Okay, so this is the structure which we people are having, and here is the path. Okay, so this one is connected to the pointer. Now we are applying a pressure from this part, and pressure will try to move in this particular direction. Okay, so when we are increasing the pressure, this is going to be elongate one. This will try to be traced in the outward direction, and when it is moving in the outward direction, at that time this pointer will try to move either forward or either in the reverse manner. Okay, so this will be deflected over here, and we people are going to get the resultant output at the terms. So we can easily indicate the output, whatever may be the SI unit, or either in Pascal, PSI, bar, torque, whatever may be the unit that is present. Likewise, we can utilize that sense for the measurement of the pressure. Okay, so these contents we have seen, and as it is related to the elastic mean, we are trying to measure the pressure depending upon the inputs. Its deformation will take place, and the pointer will try to move as per the input pressure which has been applied in terms of deformation. So that will be deflected on the scale. Okay, and similar contents we people are going to carry forward in this one, in this particular lecture, that is nothing but our 18th lecture for pressure measurement. So in after completion of this particular lecture, you people will be able to specify the different types of elastic type of pressure measuring devices that are commonly used in the industrial application and day-to-day life. Its working principle, its constructional detail, and the content. Here, in the first lecture also, I have already specified you people regarding the definition of the pressure, that it is nothing but the ratio of the force per unit area where we people are applying, and the different units of the force pressure measurement in the industrial application. So what are the different types of elastic elements, and how that elastic elements are feasible for the measurement of pressure? No doubt that the elastic elements which we people are using, that elastic element is subjected to the pressure so as to deform it. And for this aspect, I have represented one of the rubber or rubber band for your better understanding. So here we people are having the rubber band, and if we are applying some force or exerting some force on this one, either to the external side or either towards the internal side, then what is going to happen? This rubber is going to be a elongated one, and it may form the structure like a deformation after applying a force on it. Okay, so here force, pressure, whatever the input parameter we are applying, that is going to be exerted on, because pressure is nothing but pressure is defined as force per unit area. How much force we have applied on what area that force has been applied on it. So here the force that has been applied on the elastic element is going to be deform that particular elastic element. Okay, so this concept is incorporated for the pressure measurement. So the measurement is totally depend upon the deformation which has been carried out. It will try to provide an indication of the pressure value. So what pressure value we have applied, so that particular pressure value is going to deform the input or deform that elastic element. So that particular deformation which we are arising, or that deformation arise due to the pressure measurement, or for the measurement of pressure by utilizing the mechanical or electrical means, we can measure that one by using a secondary transducer. Because what happens, direct measurement which we are measuring using our dial gauge may indicate the terminology in the form of analog output that can be represented with help of our naked eye. But here in this one, what is going to happen when we are using the secondary transducer? Suppose capacitive type, suppose inductive type, LVDT. So the core of LVDT can be connected to the tip of that particular Bourdon tube. As an example, I am specifying. So there are large number. It may be bellows, it may be your diaphragms, and many more. So suppose, for example, I have connected that core of the LVDT to the tip of that particular this one particular Bourdon tube. When pressure we are applying and when it deforms, at that time the core which is connected will either move in the forward direction or either move in the backward direction, depending upon the pressure which we have applied and what is the strength of the pressure. So the strength of the pressure which we have applied, that particular pressure applied will deform the particular Bourdon tube, and in proportion to that the core will vary. So the movement of the core will try to generate an output. Okay, so for this particular example, for the elastic element along with the Bourdon tube, there are diaphragms, then capsules, then bellows, Bourdon and helical tubes. These are nothing but these are the examples of the elastic type of elements. Okay,